think we're live now. All right. So today I'm going to try and just do a typical shader in Godot that looks like water in 2D. So basically my plan is to do a 2D shader that will allow me to simulate water in the Godot game engine. So what I want to do is that I want to get okay, the kind of what I want to simulate before I start coding, so I will just map it as that. I want to simulate that um, if you hover across the screen, you will like the water. You want it to be as if you are like swiping your mouse through the water. Then, if you stop your mouse at a particular position, then the water will be emitting from that exact position. Otherwise, the water will just be emitting from maybe the center or something like that. But the first thing I want to do is like I want to create the mouse ripple. Then I will maybe let me look for water texture. When I use a water, yeah, we'll just use a simple water texture. I know that this will work. This is going to be the first I'm going to be working with texture. Let me put this in my learning Godot VFX folder and save it there. So this is first going to be the first I'm going to be working with texture. So hopefully this will be enough to simulate it. But aside from that, we'll need to also work, but we'll do it without texture first because I'm more comfortable without texture. So the first thing I'm going to do is I'm going to get a uniform. I'm going to call this uniform mouse. It's going to be a vec2. And it's going to be the mouse pulse that we're going to be sending in from the game engine here. Then maybe later we'll do a sampler 2D and put in a texture. But for now, that's enough. So the first thing we want to do is that okay, to simulate water, how what is water? Let's just paint the screen blue. So let's just screen color and let's make it equals to um vec 4 and we'll paint it blue. So that's RGB. So that's 0.0, 0.0, comma 1.0, comma 1.0. So we just have a blue rectangle. And this blue seems too strong. I think we should add some green into it. Let's say let's make green. Let's make green 0.5, 0.3. Let's do 0.3. Let's increase it to 0.5. Well, as a solid color like this, it doesn't matter how much I increase the green. But let me still increase the green small. 0.7. Okay. All right. So let's assume these are water. So what we want to do is that we want to put sine wave anywhere we have the mouse. So the first thing I want to just do is that I just want to just put a sine wave emitting from the middle to go outward. So like a sine displacement wave. But why are we actually going to displace? Because I know that sine wave we best let's say model how we how water will behave, but why it best does that? There's no depth or anything to this water. So I don't know how I'm going to do that. Let me just create a water load. The water waves. Sweet dream I made of. Who am I to say? Let's just consider this question a little bit more before we work on it because let's decode it. I want to create a water shader using Godot color. Right. Don't write code. Just tell me about the problem. Your problem dey for your back, oh. And you wonder why men not come around, oh. Every other day follow you, Baba. So I just want you to just chat with me about the problem so that we can get like more idea. So creating a watershed and Google current is a fantastic way, a lightweight way to make 2D water like a screen dash space water effect or a localized pond. Blah, blah, blah. However, because the color rate is flat and 2D plane that renders a solid color by default, you have to fix all the physics and depth and reflection math texture isolation problem. By default, the colorX only knows about its own tiny world. It doesn't know what's happening behind or around it. The challenge water needs a distort background to look realistic. The problem if you apply a standard shader to a color rate, it only manipulates the color of the rectangle itself. To fix this, you have to force the shader to grab this behind it and tilt the screen texture. Managing how to it samples the background without causing weird visual glitch. Just start. So I just want the rate to emit a sine wave from center. Okay, yeah, the first task is to shift the what happened? Okay. So the first start is to actually shift the center of the UV coordinates with let me log this up. What's the issue? Sorry. Right. So to shift the center of the UV coordinate, you just do UV. We just create a vector, and we'll call this UV. Let's use small letter UV centered. I'm going to give you the value of UV minus what you call it now? 0.5. Just minus 0.5 on the UV, and that should center the UV. To prove that the UV is centered with that, what do I do with the UV? Let's just say it's centered. I don't know how we prove it to you, but it's centered. I can like make a gradient now. Yeah, let me just make a gradient that should originate from the center. I think to do that, normally if you were to do, to do a gradient to the center would be much more work than this. So you cannot just impute the value of this thing instead because if you do that, what you will see is will be a very funny thing to be, let's say, UV centered. Basically, for the topper part, it will be just dots. Let's say dot x. It will be just red. If I say red, it will be colorless in the negative axis. But I don't know how to explain it. For this part, it has no influence because it's zero. Godot shader cannot have negative values, so it will be zero for this side until you get to halfway point of it before you will not get something. So that one is not really a good example of trying to show that the same thing. But we'll just leave this first. Let's go back to um, the tags. But I've centered the UV. Just keep that in mind. Or I'll just keep that in mind. Distance formula. Create a circle. Okay, yeah. To create a circle in shader, you use the distance formula. Basically, what you're trying to say is that the distance between the radius of the circle is the distance between the center of the circle and is the distance between the center of the circle and the point where you are. So because shaders, a circle is a when I say a symmetrical shape where all the points in the line has an equal distance to the center, which is the radius. So if we calculate the distance of the circle, we can form that circle using different functions. Like we can use a step function to color to color to color the UV in that exact point a particular color. So let me just create the distance. So let's say let's call this uh, wave. Let's call it wave circle. So it's going to be a floating point number wave circle, and it's going to be equals to. I'm going to save it as the distance. No, the length of. Then we're going to pass the value of UV centered. So now we have the length of UV centered. So now what are we going to do? The distance formula. So for the distance, aspect ratio. Okay, unless we have a 500 by 500. Okay, so basically what it's saying is that it's warning us that if you do not solve your aspect ratio problem, you're not going to get perfect circular this thing, because UV, why UV is the normalized number. Our aspect ratio is not a perfect aspect ratio. So we need to technically scale it. So what we need to do is that we need to make one of the axes equals to 1. Then the other axis will be equals to whatever it should be equal to. So we need to scale it up or scale it down. That's what we need to do. So what was the recommendation? You said solution, you need to pass the actual pixel size of the color rect into the uniform, then multiply the XY coordinate by the aspect ratio to normalize the space. Okay, yeah, yeah. So basically, give the get the aspect ratio. We can just come here like this. But instead of doing aspect ratio, let's just have use. Okay, let me get the aspect ratio. Uh, yeah. Where would I get the aspect ratio from now? We didn't assign it an aspect ratio. Okay, country A, country C. So let's do vec to let's call this AS, and let's make it equal to um vec to, we'll paste this as command, we'll paste this here. So I think that's correct for the x and y axis. Yeah. So these are aspect ratio. So I'm not going to come down here because we don't really need this value. We're going to say AS is equal to, that's the aspect ratio is equals to aspect ratio dot x over aspect ratio dot y. It's going to become a float now. ASR. Let's just simplify. So now with this float, now this float value is our aspect ratio. So the aspect ratio is going to say whether our screen is wider than it is long or is longer than it is wide. As you can see, our screen um is wider than it is long. So now we're going to multiply the aspect ratio by solution. You have to pass the actual pixel size of the color into the shader as a uniform. Multiply the x and y coordinate by the aspect ratio to normalize the spacing and force the circle to stay perfectly round. Okay, so we just need to multiply. So sorry, let's cancel this. Then we'll cover it, wrap it like this to ensure that it performs the operation in the way we want it to perform it. Then multiply by ASR. So this should have our aspect ratio fixed out. Then make it move. Same way static. So yeah, we know. Okay. Control C. Did you say my way? Okay, so by subtracting sine from the distance before passing it into the sine wave, you treat. Okay. Okay, so Oh god, when I woke up this morning, I could draw this thing. Like I spoke to myself about how to draw a water way. I don't know why it's not coming to my head right now. Okay, so what I'm going to do, I'm going to make this a mix. Then I'm going to put a black color. So like, or let's just make it white font so as to just be easy to type out. Like for let's just make it 1.0. So then I'm going to put here, I'm going to put a step function. And in the step function, I'm going to say I'm going to say let's use a small step because I want to put two values in. So basically what I'm trying to say is that edge, float edge, then value. Okay, edge one, edge two. Okay, so edge one will be water wave, comma. Edge two is going to be uh, water wave plus points 0.0, comma. Then I'm going to make this. Is that this is a very small step? I've never tried. Okay, we are getting there, we're getting there, but we're not there yet. First and foremost, this step function that I defined, I didn't define it properly. The thing is that I've never actually used this smooth step. I know that this smooth step exists, and I know that this smooth step is actually kind of the right choice for what I want to do, but I do not know how to implement a smooth step. So let me give AI my code that I've done so far. I said it. It was this language that confused me. What they are saying I should do is that I should let me just show what they are saying I should do. I'll comment out the line. I'll comment out this line. Then I'll just repeat it. So what they're saying I should do is do this. And what it's going to give me is going to give me something very, well, I say, not really water looking. So what they're saying is that I should use water, but I should make sure that it is, I should multiply it by 0.5 so that if I multiply by 0.5, I will reduce the wave size 0.5. This will reduce the wave size to half of what it should be. Then I should not add, wait, I'm going to put it in brackets. plus 0.5. So this will not add the height back into the wave. Then for the alpha channel, I will now make it 1.0 so that it will not be transparent. And because it's supposed to be a vec, so this is what they want me to do. Like I said before, it's kind of like a gradient water, but this is not water. So basically, what me I'm trying to do now is that I'm trying to have a circle go through the water instead. So that's what I'm trying to do. I'm trying to have a circle go through the water instead. But the thing is that my smooth step is wrong. The question is, how do I define a smooth step? Let's look in another context window so I does not give me the answer. Explain smooth step to me.
If you've ever worked with computer graphics, game development, or animation, you've probably run into smooth step. At its core, smooth step is a mathematical function that takes a number and clamps it between 0 and 1, but with a twist. Instead of a straight, rigid transition, it creates a smooth, S-shaped curve. It's the secret sauce behind smooth transitions, fading effects, and soft edges in shaders. The intuition, linear versus smooth step. To understand why smooth step is so popular, compare it to standard linear interpolation, often called lerp or a linear ramp. Imagine a car accelerating. Linear ramp, lerp. The car instantly jumps from 0 to 60 miles per hour, holds that exact speed, and then instantly snaps back to 0. It feels incredibly jarring and robotic. Smooth step. The car gently speeds up from a standstill, cruises at a steady pace, and then smoothly brakes to a stop. It feels organic and natural. How the math works. The standard smooth step function is typically written as a cubic polynomial. If you feed it a value x that is already scaled between 0 and 1, the formula is. If you plot this formula on a graph, you get a beautiful S curve. The three controls. In code, smooth step usually takes three arguments. Smooth step, edge 0, edge 1, x. Edge O, the lower bound. Any value of x below this becomes a flat 0.0. Edge 1, the upper bound. Any value of x above this becomes a flat 1.0. X, the input, the value you are testing. If x is between edge 0 and
Oh,
edge 1, it
oh,
gets
wait, wait.
smoothly interpolated.
If any value below this become a flat 0.1, edge 1, any value above this become a flat 1.0. That's the issue. That's the issue. That's the issue. That's the issue. That's not what we want to do. We want a situation where any value any value below this becomes flat 0. Yeah, okay, this we the values below this being that is fine. The values above should not be one. So yeah, Kiyomo, 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 nemi, 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 nayo, Kiyomo, 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 nemi, nemi, nayo. Nike don't pay me to tell you I do it. They pay me to show you I do it again. Do Ah, Sass. Why can't I figure this out, man? Why can't I figure out how I'm going to write this simple thing to get it to do a circle? I'm supposed to. I want to write that. What I'm actually trying to write is as long as it's within this bound. Let's see. Let's see. What do I do? Okay, I can use a double step function to cheat. So what I can do is I can do step and do another step, then get the minimum value of the step. So The first step, the first step is going to do um water wave. Then it's going to say water wave. Then if the water wave is oh my god. Logical says you are just being an idiot. Wait, wait, no, no. This is not making sense. This step function, if water is less than water plus one, it will output one, and it will output zero. If water becomes greater than water plus 1, it will impute 1. Then this one is now saying if water is less than water minus 0, it will impute. If water is greater than water minus 0, it will impute 1. So basically, these two functions, one is saying, let me just write it in the top. One is saying water with water with greater by 0.1 equals 1 less equals 1. Max, if any of them is up to 1, they will both be 1. Meaning, if anyone is less than 0, if anyone is less than 1, they will both be 1. But the issue is that this setup that I have, wait, if I just invert it, so minus 1, minus 0.1, okay, so now what I'm saying is if water wave is ish. Okay, I need to just do a simple if statement. I'm not happy with what I'm doing. Okay, let's look at the code. Um, so this whole part is my previous code. This is my previous code. Then what it did is that it sped up the wave by multiplying it by 20. It sped up the time. So now that we have this, what I want to do is that I want to send in the mass coordinates with Godot. So I'm just going to create a script here, and I'm going to call this what I'm just going to say. I'm going to make this a tool as tool. So I'm going to come down here in the process function. I'm going to say get mouse global position. I'm going to leave that here for now. Then I'm going to say on ready. I'm going to say uh, var equals to color rect. I'm going to set it equal to dollar sign color. Then I'm going to come here. I'm going to say color rect dot get shader. Then I'm going to say I beg give me with the syntax. Man, no, Chris. Okay, wait. What I'm supposed to do is a get shader parameter. Was that on track? Get instant shader parameter. That was wrong. So once we just get, I'm supposed to get material first. The get shader parameter. So the get. I'm gonna do material. Material dot get. And this stuff takes in an input of name, and the name is mouse pause. I'm going to set it to So they say I should put var mouse equals to get. Godot does not support vector, it's vector 2. It does. So, um, vector 2. And this is not even how it defines it. So you can just simply do a variable. It has type sense to know that this is going to be a vector 2. So the normalized mouse position is equals to, now what we just do is mouse divided by, okay, it's not get, it's set. So if I save this now, I come here and I reload. I should be getting normalized mouse position. All I used to do now is clamp it to UV. This is normalized mouse position. Now I need to just clamp it to UV so that it does not um, exceeds the threshold value. I'm not going to read that code. Let me come back here. So, where were we? Water.gd. Okay. So now, the first thing we need to do is come here to mouse pause, and we're going to just say mouse pause. Let's just call it mouse. Mouse going to be a vec. So we're going to say is equals to, going to clamp mouse pause to a minimum of vec soon, or all 0.0, comma, and a maximum of vec2 of 1.0. So if the value exceeds that, we do not care. Then, what else do we want to do? Oh yes, yes. Now we want to make the wave to be in where we want. So instead of doing UV dot centered, we'll mouse pause here. So we just put mouse. But this, I think that's okay. Oh, no, sorry. Yeah, no. Yes, Ali, 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 Ali. Wow. Actually, no. Okay, now what I now needed to do is that I needed to have a velocity and acceleration. Let's return back to our previous chat. Oh, but it looks fine now. This is the best now. It's properly scaled. What is it talking about? All the changes or whatever. I don't know. Maybe it's because I'm not reading the whole statement. I'm just scanning through. The mass vector is perfect. Oh, wait, no, no. I don't even need to ask it. Velocity distortion basically means that if the mass is going towards, like, this is not something you can do with shader. Oh. Basically, what velocity distortion is the magnitude of distortion. That's the magnitude of change in x and y will multiply the wave, what's the sine wave now? The distance. We'll multiply the distance by it to reduce it. But I don't think I will need to use my GD script. I was doing my network now. Is the OBS loading well? See now, you have memory problem, tracking speed and velocity. Because shader can't look backward in time, you cannot calculate velocity inside the shader code itself. Problem, if you just pass the raw mass position, the shader has no idea if the mouse is sitting perfectly still or sprinting across the screen or moving left versus moving up. Solution concepts. So you have to calculate the velocity vector outside the shader. If in a GD script, every frame the script must subtract the previous mouse position from the current mouse position and multiply it by delta time and pass the resulting vector velocity vector into the shader as a new uniform. Symmetrical versus asymmetrical distortion. Right now, your wave uses length UV center, which creates a perfect uniform circle because it measures the distance equally in all directions. The problem, the mass moving quickly to the right, the water should compress in front of it and stretch out into a long wake behind it. Yes, exactly. Solution concept. You have to use a new velocity vector to wrap the UV center coordinate before they pass into the length function. By subtracting a portion of the velocity vector from your UV coordinate, you skew the distance calculation and the shader within the pixel behind the mouse is farthest away than further than they actually are, naturally stretching the sine wave into an aerodynamic teardrop shape. Okay, So in GD script, I need to okay. So what I need to do first is create a uniform wave and call that velocity. Uniform. I'll call it vec to velocity. Then I'm going to go to GD script and I'm going to do. I think I should be spending more time like really understand this thing after I read it, so that I don't come back to check it again. So that it's as if I actually learned it instead of actually taking their step by step. Okay. So because the shader can't look backward in time, you can't calculate velocity inside the shader code itself. The problem, if you just pass the raw mouse position, the shader has no idea if the mouse is sitting perfectly still, sprinting across the screen, or moving left versus moving up. The solution concept. You have to calculate the velocity vector outside the shader in a GD script. Every frame, the script must process the previous mouse position from the current mouse position, multiplying by the delta time and passing the resulting vector to velocity vector into the shader as a new uniform. So we need to look at we need to get the previous mass pulse and the current mass pulse and multiply by data time. How do I get my previous mass position? Hmm. That's an interesting question. I don't understand Godot up to that extent. So, um, this thing is bugging me. Like, it's really bugging me. Oh my god. I do not care if you could not load recent charts. I can't hear you. Oh, leaves in a pineapple under the sea. Every single frame during the process data loop, your script performs a specific sequence of events. Step one, you get the current position. You call get mass position and save it to your current variable. calculate the difference. You subtract the previous position from the current position. This gives you the okay, wait. Every current position you call get, okay. I'm already calling get mouse position. Okay. So basically, we need to change this stuff to okay. Current mouse equals to get current mouse equals to get current mouse position. Oh, Sas, are you stupid? So I'm going to just delete this. Then here we're going to use the current mouse position. Okay. So what next? What's next? What's next? What's next? Uh, well, no. Before we use the current mouse position, we have to before we normalize it, we have to actually. I think we have to divide it by vector. Calculate the addition. Okay, no, it's a difference that was also continuous position. They'll say velocity is equals to current mass position minus pre. What's wrong with my shader code? So now that I have velocity, let's work with our velocity. Oh God, I forgot to paste this thing first. Okay, so I don't want to waste so much time on Godot. What is their over commented code? Okay, so now we have the velocity. How do we convert velocity to displacement? Imagine you're dragging the mouse to the right, positive velocity. If you subtract a bit of the velocity from the UV coordinate in pixels behind. Okay, first, skew the coordinates. Skew the coordinates, the vector subtract. To create a wake that wants the wave to squish together in front and the mouse front of the mouse and stretch out behind. To achieve this, you achieve this by subtracting a portion of the velocity vector directly from your UV centered vector. need the coordinate. To create a wave, you want the wave to squish together.
Video, we're going to go over the different shapes of distribution. So what's the difference between parallel lines and skew lines? What do you think the difference is between these two?
I don't think this is what I need to. I can't figure it out, so I can't interpret it consciously. I'll work this night. Hopefully, if they bring light, I'll come live. If not, I'll have to stop now. So I was not the one who's wrong. So. Oh, wait. No, no, it's still part of this circle. The only thing that's just happening is that it's as if it's bouncing. I mean, this is an interesting look, but not quite the. Beautiful. Okay, I need some sleep. If there's light this night, I will stream in the night, but if not, till tomorrow. We will create the project later today. I'm going off right now.